Okay, so essentially I want to talk about, vector or tensor representations of group. Okay, so it makes it much more easy to talk to discuss this issue in the context of a particular group. So let's just take SON or ON, doesn't matter, but for definiteness, let's just talk about SON. In fact, I will have something to say about ON, but yeah. So for these groups, there is the defining representation, right? So the defining representation, what will it be? It'll be some sort of n by n matrices, right? And they act on some vector space. So they act on a real vector space, whose dimension is n. Okay, so in the case of SO3, we know that these are 3 by 3, orthogonal matrices. And, well, we usually write the SO3 elements as R because of the rotation, interpretation, but they act on 3-dimensional vectors to give you other vectors which are rotated. So SO3, acts on R3 as a vector space. Okay? So this representation we call a vector representation. And this is the fundamental representation of SO3. Essentially, we have a vector I. So for SON, let's go back to SON. We have some vector whose components are 1, 2, ... n. And under our SO3 transformation, what happens is that VI, the components get changed by a linear transformation like that, where R is a matrix of SON, right? And the thing that if I write the inner product of this with itself, the dot product, that's this thing, V transpose V, or you can write it as V dot V. And that thing under an SO3 transformation becomes V dot V prime dot V prime, or V prime transpose of V prime, and that thing remains unchanged. Okay? So far, everything should be clear. If it's not, you should speak up. So let's look at some SO3 vectors from physics. So for example, any 3 vector, like say a velocity, right? Or acceleration, they are SO3 vectors, right? Under a rotation, how does the components of acceleration change? It changes up to a rotation matrix, right? So other examples are, so if I go to electromagnetism, if I take the electric field, right? So that is another one, or it's probably better to write it EI. So under SO3 rotation, sorry, I should write it just as R, not Rij E of j. And B is also an SO3 vector. Okay, but the scalar phi, which is defined to be, well, it's defined to be the gradient, the minus of the gradient of the, of the scalar is the electric field. Is there a minus sign? There is, right?
Yeah, there is.
Yeah, should be, otherwise it would be unconventional. So, this is under rotation, it just remains unchanged. So this is a scalar representation or a trivial representation of SO3, right? There is no R matrix. Okay, is that clear? So now what we want to do is that we want to build up bigger representation from the smaller representations. So bigger, but at the same time, irreducible representations. So if I now go to, say, the Lorentz group SO1, 3, or even O1, 3, then these guys, EI and, say, BI, are no longer, vector rep of the Lorentz group, right? Because a vector representation of the Lorentz group should have 4 components, right? Whereas these things only have 3 components. So these 3 components are representation of the SO3 subgroup of the Lorentz group, but this thing is not a representation of the full Lorentz group. So we need some kind of a vector. So for example, if I take, say, ds mu, which is, say, x1 minus x2 mu, so these are 2 coordinates, right? Now this thing under Lorentz transformation, this will goes like this, right? And so this is a vector or representation of the Lorentz group SO1, 3. Okay, because we see 1 copy of the Lorentz matrix. Now, what if I take, so there could be a generic vector, let's call it V mu. So that would be under the Lorentz transformation, this would be a contravariant vector representation. This would be a covariant vector transformation. We are not so bothered about the covariant, contravariant right now. But suppose I'm given 2 vector fields. Let's call one, say, V mu and W mu. Okay, so each of them are vector fields. Some vector representation. Okay, they could have some physical significance, but I don't care. So these are both E-reps of SO1, 3, vector E-reps.